Okay, so today I am going to discuss about test of hypothesis and confidence interval. Okay, there are I think around 20 or 24, 5 problems. I'm going to give you first the background, what is confidence interval, and then I'm going to discuss test of hypothesis. I give one or two real life example by paper and pencil, the steps, the procedure, what does this mean? After giving that discussions, then I'll go to use R to show you the output and how to interpret the result. Clear? Okay. I'll show first on paper and pencil what is confidence interval. Right. So confidence interval, you sometimes say, okay, what is the difference between probability and possibility? Can anyone of you tell what is probability and possibility? Which I'm going to discuss next class, maybe week after next week, maybe. So possibility means yes and no. Okay, possibility. And probability means with certain level. There is a 70% chance of raining. Okay, certain level of confidence with the predictions. There is a 80% chance that Los Angeles Lakers will win against Cleveland. Something like that. Understand? So now we will say 70%. Right? I say 90%, 95%. How can I get those 95%, 90%? You can say, okay, I'm 95% sure that the proportion, like the probability of winning the game by Los Angeles Lakers against Cleveland Ohio is 92%. You said 92%. And someone walking there, he said that, how? How can you get? You said 92%, so then find the probability, proportion of that one. Understand? And she said that no, I want it to be like 82%. How 82%? Where did you get 82%? Okay, so these are the things I'm going to discuss. So let me start writing in here. Take a look. Suppose this is the mean. Let me go there. Take this. And I want it to be like this way. This is, and suppose this is the mu, which means tan. Okay, mu means what? This is Greek letter mu. It is usually stands for the mean or average. Okay, mean or average. Okay, so mean is 10. Okay, so now mean is 10. I want to write like this way a line like, oh, how can I do this? You are also laughing. Okay, okay, let me see if I can do a straight line in here. Come. Okay, this is a mean. So mean 10 equal to what? Average amount of money spent for lunch by the USM student. Understand? Someone said that average amount of money spent for the lunch by the student at USM is $10. Okay? And someone claimed that from previous year. So we have decided that we will test it. Okay? I send this girl to suppose 100 student. I send this girl. And then he went to the 100 student. Okay? How many student he went? He went to the 100 student. Okay? He went to the 100 student. And then this is the formula x bar plus minus z 0.95 s over square root of n. Clear? Understand? So she went to the 100 student and student said that I spent $13, another said $7, another said $10, another said like $15. In that way, 100 numbers you have from 100 students. From those 100 number, you can easily compute X bar, right? She computed X bar. And then she computed the standard deviation S. This is known as the standard deviation. The S is known as the standard deviation. This is known as the standard deviation. This S, standard deviation. This is n equal to 100 and this is the 95 value. Okay. And then she plugged this value. So when she subtracted, she got a number. When she added, she got another number. Clear? Understand? And then she plugged this value comes in here. When she added, she got like 13. When she subtracted, she got like 8. Understand? So that means this is her data, 100 data points. From there, she computed X bar, she computed standard deviation N, and this Z.95. How can you compute Z.95? Now I'm going to show that one. Z.95 is this one. Standard normal. This is your symmetric curve. Okay. This is your symmetric curve. And she won 95% in here. Middle 95%. This is her 95%. Clear? Are you understanding what I said? This is called the confidence interval formula for mean. This is for confidence interval formula for the mean. Very nice question. This is the confidence interval formula for mean. 95%. It could be 92, 93, 97, 82. How can you get that 95% value, which now I am showing? Yeah, when mean and standard deviation results will be given from the data. She went to 100 students, right? 100 students gave her 100 numbers, right? $7, $13, $20. And she averaged them, she got X bar. She find the standard deviations by using the formula that I gave in the first exam, and she got the X bar and S, right? From the 100 number. And she has N equal to 100. And what is Z.95? Now I'm showing you. Okay? So come here, this is equal to, this means in this area, 95% of the frequency fall in this area, okay? In this area. So I have to find this value, which is called the Z.95 negative, and here is Z.95 positive. Okay, now I have to find what is this value, what is this value. Are you understanding? Within that, 95% frequency falls. If it is said 82%, you have to find 82%, middle 82%. Remaining 18% will be in the extreme tail. Understand? Clear? So now your question is, how can we find this value? Okay, take a look at that. This is equal to what? Can any one of you tell me? If this is equal to 95, how much is in here? 0.025, right? And here is 0.025, right? Clear? Everyone okay? Now take a look. How can I find this below? I have to go to the R and I have to come in here. And then I have to find here Q norm 0.025, 0.1. And then I got negative 1.95, right? Q norm. Q means quantile coming from normal distributions for 0.25%, 2.5% frequency less than from that. So I want in here in order to find the 2.5% frequency, try to understand these things. Okay, please take a look at the board. In order to find 2.5% frequency, what will be the Z value? Z value is negative 1.9555, which is 1.96. Understand? Clear? Now, if you want to find this value by symmetric, you just put here positive 1.96. Okay? But if you want to find this one by using this, so if you want to find the frequency for entire these things, if you want to find like all of these things, so that is equal to what percent? that is equal to 0.975, right? This green area is 0.975, right? Are you understanding? So now in order to find that, I have to go there and I have to come here 0.975. Are you seeing exactly same number, but sign is different, right? Here. Okay, he said 0.82. Should it be 0.82? Okay, I want to give you one more chance. Okay, so come in there. Yeah, so I want to put these things. This is my 82%, okay? Now tell me what should I what value should I put? Here is 82%, right? Here is 82%. Now how much is in here? How much is in here? How much is in here? This is in middle, this is 82%. How much is in here? How much is in here? 9. Right? Here is a 9%. And then here is a 0.9%, right? Now I have to write here. Tell me what should I write? Q norm. In order to find this one, what should I write? 0.09 and 0,1. Then it will give you this value. Understand? Are you understanding? Now, in order to find this one, what should I write? In order to find this value. This one. I found this one, right? I already found this one. Let me maximize these things. 0.91. Who said this? Okay. 0.91. So 0.91, right? Let me see if I can find the bigger one. Is there anything that I can make bigger? There is something. Let me see. More color, thickness. Let me see if. Okay. It is still not that. I want this cursor to be big so that I can. So why he said 0.91? Because 0.91 means this, all of this. Okay. So that means you have to put here 0.910, 1. Understand? And why you did this? Because you want to find this Z value, right? Okay. So now if I said 72%, 93.5%, 88.7%, 79.2%, you can find it, right? So all the persons that I ask, it will directly go to the middle. Okay? Remaining parts you have and put in the two tail. And then you have to compute this value. Are you okay? Now okay, are you okay? Demonstrate that in your. Q norm 0.09 and 0,1, you are getting this value. This is the negative one, and then the positive one, if you want, you just put here 9,1. Same value, but the sign is different. Are you seeing? Because normal distribution is a symmetric distribution, right? Good question. If it is normal and T, then you can compute one, and by symmetry, you can write the other one. If it is normal distribution and T distribution, how? You will learn all of this. You will learn all of this. This is the normal distribution. This is the normal distribution. Sorry for bad writing. And this is the T distribution. Oh. This is the T distribution. Let me draw it again. Let me draw it. The drawing does not look good. What happened? Why you are disappearing? What error I did?
I think that it's just writing the line.
Okay, so let me see. Okay. So this is your normal distribution. Okay. And it has a, here is the mean, which could be 0, which could be some number. And T distribution is this one. T. This is called the T distribution, which I did not discuss yet. T distribution, which will be discussed soon. And this one is normal distribution. So you ask the question, if I find one, and then rest one, if I just do transferring it to the positive, yes, the answer is yes for normal and T distribution. But other distribution, F distributions, chi-square distributions will not follow this rule. Clear? When I will discuss these things, I will explain. Believe me, keep coming to the class, try to understand, focus. You will understand these things and all of this concept will be clear to you. Okay?
Use the same T score and C score, or
Yeah.
if it's positive on one,
Yeah. So T and C follow the same. If you find one, other one just does changing the sign. Okay. But chi-square and F will not work that way, which I will discuss. Okay. Now what I discussed so far, I am discussing confidence interval, right? In the confidence interval, when I started discussing, I wrote the formula. Then this gentleman asked, what is the formula for? This is the formula for the 95% confidence interval for the mean. Okay. So she constructed this one. Her confidence interval covered the true population mean 10. Okay. Now she went to the another 100 student and she got X bar and S and N. She computed another confidence interval. That confidence interval also like this. Okay. This confidence interval like this. It could be like 7. It could be maybe 15. Okay. So that means her confidence interval also covered the true value of me. Okay. And this gentleman went to the another 100 student and his one does not cover these things. Why? Because he went to the student maybe who are very health conscious or who are very poor, who does not spend a lot of money for the food. Are you understanding? Are you understanding? So that is why when he computed confidence interval, that is not covering the true mean. The true mean 10, it is coming from the last year information. Okay, now this year I am. Now again, this gentleman went to the another group of 100 students. He collected their amount of money and he estimated X bar and S and N, and he found that his one is in here. Okay, it does not cover. That means he went to the students who like food or who spend a lot of money. Okay. So on an average, if we continue these things 100, 200, 300 times, 95% of the time, this confidence interval will cover the true mean. That is the explanation. It is a long run situation. It is not like exactly 100 sample will come. You will collect one sample, she will collect another sample, you will collect, and I will collect. We 100 people collect 100 sample and 100 this confidence interval we constructed. Exactly 95 of them cover the true mean. That is not the answer. It is approximately. Some in first 100 maybe 92%, second 100 maybe 97%. In the long run, if you continue it, take 500 samples on an average, 95% of them will cover the true mean. That is why it is called 95% confidence, because I am using 95% Z value. Are you saying? So 95% Z value means what? Normal distribution. When you put the data to construct the histogram and at the top middle point of the each bar, you got the frequency curve that look like symmetric. So 95% frequency fall within two standard deviation. That means 1.96. You saw the number 1.96, right? 1.96 is approximately two standard deviation, right? Understand? So this is the basic of confidence interval. If someone asks you what is confidence interval, what is confidence interval, you will explain these things to you. And good questions come from you and you. T distributions we can use same. And you also ask me what is the formula. Formula is this. But there is also formula for the confidence interval, for variance, and for correlation coefficients, all of these things. But it is just I showed you one. More discussions will take place when I will start discussing these things by paper and pencil approach. Okay. Okay, so this is about discussions about what is confidence interval. Okay, after confidence interval, now I want to do another concept I want to discuss, which is called test of hypothesis. Okay, test of hypothesis. After these discussions, then I'll go to the R and explain all of these things. Test of hypo. After class today, one student is sitting with me, right? For some of the R problem. You or she? You. Who is sitting with me after class today? You. Yeah. Okay. Yeah. Now, test of hypothesis. Test of hypothesis means what? Let me give you some. Hypothesis means what? Any assumption or statement is called the hypothesis. Okay, this is the definition of the hypothesis, any assumption or statement. So now what is null hypothesis? Null hypothesis definition is, if you want to write, you can write it down. The hypothesis that we want to test for possible rejection. The hypothesis that we want to test for possible rejection is called null hypothesis. The hypothesis that we want to test for possible rejection is called null hypothesis. Okay. Any hypothesis other than null hypothesis is called alternative hypothesis. Okay. So three definitions so far I discussed in last 1 minute. First one is, what is hypothesis? Any statement or assumption is known as hypothesis. We say your hypothesis is not correct, right? What is null hypothesis? The hypothesis that we want to test for possible rejection under the assumption that it is true is called the null hypothesis. What is alternative hypothesis? Any hypothesis other than null hypothesis is called alternative hypothesis. Okay. Now, any test of hypothesis has 4 steps. How many steps? 4 steps. 4 steps. Okay. Number one is setting up null and alternative hypothesis. 4 steps. Setting up null and alternative hypothesis. Number 2, Computing test statistics value. Computing test statistics value. Okay. Number 3, getting table value. Getting table value or p value. Okay. And number 4, decision. So if I ask a written response questions, you have to write these 4 steps. Okay. So let us start with a real life small example. I want to see whether it will be accepted or rejected. Okay. Clear, right? So we want to take, suppose the question is, "16 students were asked about their 16 students are asked about their sleeping habits. The number of hours the students the number of hours the students sleep the number of hours the students sleep are these are the numbers. Okay. So now, as these are the numbers, I want to compute their x bar. I want to compute their s, and I also want to know n equal to 16, right? Who write the numbers? Did you write the number? Could you tell me the number? Just a second. 7, 9, 10, 4, 6, 8, 10, 11, 9, 7, 10, 11, 7, 8, 9, 10. Okay. This is the numbers we have. I want to find the mean, which I obtain D1, and I find SD, which I obtain D1. This is the mean and standard deviation. Okay. Mean and standard deviations I have 8.5, 1.93. 8.5, 8.5, 1.93. Okay. First step, now I want to write the question. test whether average sleeping hours of the students are 7 or not. Okay. Okay. So students are 7 or not. So I put here 1. Take a look at that where I put 1. Are 7 or not. Number 2, more than 7. More than 7 hours. And number 3, less than 7 hours. Okay. More than 7 hours or less than 7. How did I write? I write 3, right? Okay. Okay. Null hypothesis is always a hypothesis of no difference. Now I want to set up this. So null hypothesis, step 1. I write here step 1. Step 1. Step 1 could be H0 stands for null hypothesis, mu equal to 7. Alternative hypothesis, mu is not equal to 7. Understand? If I stop my question in here, suppose I stop my take a look at the board, please. If I stop my question in here, null hypothesis will be this. Null and alternative hypothesis would be this. Okay. If I do not, if I do not like this, if I say more than 7 hours, then my null and alternative hypothesis would be this. Understand? If I stop in there, if I do not like 1 and 2, if I like this, then my null and alternative hypothesis would be this. Do you understand? Which pair of null and hypothesis you will choose, that must be provided in the question. Are you understanding? See, when I write the question, test whether average sleeping hours of the students are 7 or not. Or not means I do not know. Okay? Or more than 7 hours. That means second set of null and alternative hypothesis. So in the question, one of the 3 must be specified. Are you understanding what I said? You understand? In your question, one of the 3 must be specified. Alternative hypothesis is known as the researcher hypothesis. You will set it up by using your previous experiences. Null hypothesis is the hypothesis of usually no differences. Okay, so I put here 7 hours. Are you understanding? So suppose based on this, the decision will be different. Okay. Now, suppose I want to, second step is same, but third step is different. So second step, step 2, step 2. Step 2, I want to suppose here n equal to 16 and suppose data follow normal distribution. Okay. So let me write here. Suppose 16 data points of sleeping habits, data points of sleeping hours, sleeping in hours habit, data points follow normal distribution. Follow normal distribution. Okay. What did I say? Suppose those data points follow normal distribution. Okay. Or it could be T distribution. Mean test could be done either by normal or T. Understand? Wherever you will go. Mean, but two mean or specified mean, it is always T. Two mean or, but multiple mean, it is F, which I will discuss details. Okay. Now, what is the formula? Z, the formula is, I want to put here calculated values, Z cal. See, I write here Z cal, calculated value, X bar minus mu S over square root of N. Okay. So what was my X bar? Can anyone of you tell me that I computed from 9.3, right? 8.5. Okay. Draw. (8.5) and mu equal to what? Mu equal to 7. Thank you. Mu equal to 7. And then S equal to what? 1.93. 1.93. And then N equal to square root of 16, which is equal to 4, right? Clear? Which is equal to 4. So now let me see what is this value. 8.57. So 1.5 times 4 divided by 1.93. 1.1 5 times 4 divided by 1.93, right? Let me see again. Yeah, so 1.5 times 4 divided by 1.93, I got 3.10. I got 3.10. 3.10. Okay. Now step 3. Z table value at 5% level. Z table value at 5% level. Are you understanding what I said? 5% level. So it is two-sided. Are you seeing? Take a look at the board, please. This is called the two-sided alternative hypothesis because something will go to the right, something will go to the left because you do not know. This one is called the right-sided. Right tail, right-sided because greater than, okay? And that one is also known as the left-sided or left tail because it is less than. Understand? Now, 95% I said, right? This is the 95%, right? 5%. So 5%, that means this 5% will go in here and here. Here is 0.025. Here is 0.025. And this is value equal to what? 1.96, right? That I showed before, right? So this is my calculated value, right? 1.96. Okay. So this is my negative and this is the positive 1.96, right? Take a look at that. This is called the rejection region. This is called the rejection region. Okay. And this is called the acceptance region. This is called the acceptance region. This is called the AR, acceptance region. And red area is called the rejection region. Okay. Can anyone of you tell me my these 3 point this 3.10, this 3.10, this fall where in the rejection region, right? This 3.10 falls in here, right? We reject the null hypothesis. Do you understand me? Calculated value greater than tabulated value. Are you understanding 1.96? Clear, right?
After that.
Yes. So middle part is your acceptance region. If it will go to the extreme tail, it will be rejected.
But what about the other one?
Left on? Okay, that is on the number 2 and number 3, right? Which I'm coming.
So what was the 3.10?
Which one?
The 3.10.
3.10 is, are you saying calculated, right? That is calculated from the formula, right? X bar minus mu over S over square root of n. That is called the calculated value from the data I am calculating. And tabulated value is universal. Wherever you will go. If you do not like America, want to go and leave South Africa, you have to take this table. If you do not like America, want to go to the Europe, you have to take this table. If you want to go and live in the Mars, you have to take this table. You understand? But
That example now.
what?
The example you said, you go here, you take this table.
Table. But data is different, right? You collect data from America, this is one kind of data. Collect if data from Europe, it is another kind of data. Collect data from South Africa, it is another kind of data. But table is universal. Do you understand? Table is universal. So I put the sleeping habits of 16 students. If you will go to the another 25 students, it is different, right? If you go to the students in the Europe or Australia, that is different, right? So I want to test whether the average sleeping hour for the USM student is 7 hours or not. And in order to do that, I want to test it at 5% level of significance. That means extreme tail, I will have 2.5%, 2.5%. That means 5%. Now, corresponding to that 2.5%, that means altogether 5%, I have a tabulated value which is 1.96. And calculated value I am getting from formula. Understand? Now compare calculated value with the tabulated value. If calculated value greater than tabulated value, reject the null hypothesis. If calculated value less than tabulated value, fail to reject the null hypothesis. Always say fail to reject. Do not say I accept null hypothesis. Always say fail to reject. Understand? Fail to reject. Good?
So only the 3.10.
3.10 is the calculated value.
Where would that 3.10 fall on that graph?
Oh, okay. I understand now. He said, what 3.10?
What are the numbers? Like I understand up here. Where is that all that 3.10 hours of sleep?
So see, this is 0, right? Okay, let me explain these things. I did not understand his question. Now I have to clarify this. Take a look at that. This is equal to 0, right? And this is positive, right? So 3.10 will go and fall in here, right? Which is a rejection region. Now you understand? Yes.
You, when you I do.
Okay, so
And I use a different program. Language.
okay, so that means did they use p value? P where what you learned from another class, did they reject or fail to reject by using the word p value? They use the p value. Okay, p value is a different thing that I am going to show you. There is also a p value approach.
Everything I do is.
P value, right? which you will see soon. So if you want me to compute p value, that is also possible to compute the p value. So let me, I did not want to discuss the p value. If you want to, no, no. So take a look at that. The p value approach is this. If you want to compute the p value, you have to compute that probability of your z greater than 3.10. Okay. And then if z greater than 3.10, if you compute, you will see is p value is very small. If p value less than 0.05, reject the null hypothesis. If p value is greater than 0.05, fail to reject null hypothesis. That is the another approach. Okay. Now the decision is what? Decision is now step 4. I am writing step 4. If z cal, if z cal is greater than z tab, reject H0. Okay. Z cal greater than z tab. This is cal, calculated value. Otherwise, fail to reject. Otherwise, fail to reject. Okay. Otherwise, fail to reject. This is normal distribution. That is why I said if data follow normal distribution, okay, or data can follow t distributions. Okay, let me conclude these things. If n less than 30, then we use t distribution. If n less than 30, then we use t distribution. Okay. If n greater equal to 30, it is always z distribution. Okay. Now, one of you said, how about other? So take a look at that. Now, how can we handle this is the scenario, understand? How can we handle if our null and alternative hypothesis like this or null and alternative hypothesis like that? Do you understand? I already discussed this one. This one is done. Okay, now come to the next one. The next one, null hypothesis and alternative hypothesis like this way. Mu equal to 7, alternative hypothesis, mu is greater than 7. This is the first step. Our second step is same, z calculated, which is equal to 3.10. It will be same, no change. Third step, there will be change. Third step, z tabulated value. This is what you need to understand. What would be the z tabulated value? Are you understanding? Now I am showing you how to make decision for the second set of null and alternative hypothesis. There are 3 set of null and alternative hypothesis, right? Now I am showing you how to make decision whether you are going to reject or fail to reject the null hypothesis. In this case, I want to write it in here so that it will be easier for you. As it is greater than, all 5% will go in there. Previously, you 5% equally distributed in two extreme tail. As alternative hypothesis is greater than, now all 5% will be on the extreme right tail. Understand? Are you okay, gentlemen? Okay, so now in this case, if this is 0.5, how can I get this value? Take a look at that. This value I want to find, right? This value I want to find. This value I want to find by writing Q norm 0.95, 0, 1 will give me that value. Are you understanding? Now you can ask me why I put 0.95, because this is the 0.95. Okay, this is the 0.95 and this is the value will give us. 0,1. Okay. Remember, I am recording the class. I am going slowly. Everything I am going to give you all this. But just you keep your temperament cool. Try to understand. Then everything will be just a very gentle breeze, very smooth everything. Okay. He said 1,1. Can any one of you answer? Why not 1,1? Distribution, standard normal distribution always has mean 0 and standard deviation 1. You can only do that if you have a normal distribution that has a mean equal to 1 and standard deviation equal to 1. In such a case, you can do that. But did you remember I said that wherever you want, you can go and live, but the standard normal table is same all over the world. Understand? The area of a circle is pi square r. It is true across all over the world. Even if you don't go back, if you go to the Mars or Jupiter, live there, that is the formula. Another planet system, another solar system, it is always same. Understand? So Z table is same. So now I want to find it here and it should be 1.64, which I am writing from memory. But if you take a look at that, come in here. I can write here Q norm 0.95, 0,1, 1.64. Understand? So now I have tabulated value 1.64. Here is 1.64. But my calculated value is higher. So reject or fail to reject? My calculated value was what? Why fail to reject? Reject. Reject. Calculated value greater than table value, always reject the null hypothesis. Please set it up in your head.
Because it's below 1.96.
3.10 is bigger than 1.64. This is Q norm is your tabulated value. You are thinking other way. He is transferring tabulated value to calculated value, calculated value to tabulated value. Okay? Understand, right? Similarly, it will be in the opposite. Opposite one is also same. All 5% will come in here. All 5% come in here. This is negative 1.46. Now, most important thing I want to tell you. Let me take 5-second pause. Up until you look at my God-given beautiful face. Whether it is positive or negative, in your calculated value or tabulated value, always make everything positive. Compare positive with the positive. In such a cases, you know which number is bigger than the other one. You understand what I said? Suppose calculated value come up as a negative value. And then when you treat the reset the way this is negative, this is positive, how can I negative value can never be? Make everything always positive. Compare positive with the positive. But if you hate positive, make everything negative, compare negative with the negative. Understand? So this is the thing when we are undergraduate student, we are learning these things and went home, professor forgot to tell that, compare with this. And then I said, something negative comes, it will be accepted. And then the student doing group studies, no, it can never happen. It can never happen. That's something, the next day we went, so the professor said that no, make everything positive. Clear, right? The calculated value that I wanted to show you, if you take a look at that in here, in this case, take a look. In this case, if this one is smaller than that one, then number would be negative, right? Are you understanding? If x bar is smaller than mu, then this is a negative. But your responsibility, make anything comes negative, make positive, compare positive with the positive, calculated value greater than table value, reject the null hypothesis. So I have discussed in details how confidence interval and test of hypothesis work. Understand? In details. So these are all of the confidence interval and test of hypothesis will be discussed in detail in maybe 7, 9, 10, 11th week. But right now, this is the all background discussions. Now I am going to start discussing R. Okay. So I want to take 1 minute breaks. Let me want to drink some water. Then I will go over the R. Rest of the class are. You want to leave early? Who wants to leave early? You want to leave early, right? Okay. Yeah. It's all right. It's all right. I'm recording the class. I will upload it. Just involved in phone. Okay. 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 Yeah. I know you say you tell you told me. You also tell. Okay. Busy. Yeah. How far are you liking the R that I have discussed so far? I did not know that there is a R class, so I gave a heavy material. But you see, if you open your project, it's just. I've never used R. I've used MATLAB. Then you are smarter than R people. MATLAB, you have to buy the license. You get it free from the university. Yeah, but once your university is done, then unless your grandparents are super rich, right, you get some. So the materials that I have given, but your assignment, the project is very easy. Okay, project is very easy, and focus mainly on the second exam. Third exam will be the easiest exam. Fourth exam will be easy, and then comprehensive. But heavily focus on the second exam, which is probability. That's the hardest one. That one's in a week or two. Correct. Which one? Next week. No. Second exam, I think week 5, 6, 7. These 3 weeks I will discuss second exam material. Then it will be in the 8th or 9th week. This is just the project thing I have discussed. I have discussed a lot of things. If I knew that there is a R class, I should not discuss this thing. But time is gone, right? There is no way to. You're saying there is an R class? There is an R class. Data management by R, which maybe I'm going to teach. What will you learn? So first 4 or 5 weeks, this is the things you are going to learn. 3 weeks, 4 weeks, okay? And then on top of that, there are many other things. Okay. Now I'm going to start R, okay? So in order to start R, let me go there, test of hypothesis. So these are the problems I have uploaded in the way in Canvas. You have seen that, right? So see, for the variable age, SBP, weight of D3 data, test whether average age of those people is 15 years or not. Okay. See how many steps I followed, right? In the R, you just need to write one line of code. So let me go there. Test of hypothesis. And this is what all the data come in here. Okay, let me run up until here. Good. Do you want to know? Because it is already in there. Okay. Take a look at that. Age variable is line number 31. I am writing line number 31 T dot test D3 dollar sign age mu equal to 15. I am testing whether mean is 15. Alternative hypothesis two-sided. That means 15 or not. Okay. And then alternative in two-sided, that is for the SBP and that is for the DBP. If I run it, take a look at that, the result. If I run it, this is the results. Okay. Now, please give a little focus on this. In this case, T equal to coming like that. DF is that. P value is very small, right? Are you seeing, gentlemen? P value equal to 2.2 e to the power negative 16. That means after decimal point, there are 15 zero, then 2.2, then 22. Okay. So P value is less than 0.5. We reject the null hypothesis that average age of the children is 15 years. Okay. Now, where is the confidence interval? Are you seeing 95% confidence interval for the average age 12.85 to 12.69? This is the, and we tested our age equal to 15. Understand? Clear, right? In your fourth exam, when I give you the problem like this way, entire exam you can do in just 10 minutes, 15 minutes. Okay, gentlemen. So did you import the data? So see where you will get. You have to set up this root directory. Root directory you have to change. Okay. And in the same directory, you have to have these data, class practice data that I discussed before. After that, if these two runs, then rest of them thing will run. So you have to change these things. Okay. Understand? Line number 5, which is root directory. Currently, what I have my directory. Understand? You need help? You got it, right? Yes. Yeah. In a Mac computer is different. Yeah. Okay. Everyone is okay, right? Good. So now, similarly, if you want to do it for, I said here, question number 1, both sided, okay? So both sided means two sided. Similarly, this is the one, this is the another one, okay? Now left sided. What is left sided? This is the left sided. Left sided means you remember the greater than less than. So this is the left sided one. And same add as it is left sided, confidence interval you can get only for the two sided case. But if you write the left sided, are you seeing confidence interval less negative infinity? Okay. So you are not going to get the proper confidence interval for that one. But p value is still less than 0.0. So you reject the null hypothesis. So these are the question number 1 and 2. Okay. Now question number 3. Let me check what is question number 3. Okay. Question number 1, 2, 3 is done. Okay. Because the question number 1 is two-sided. Question number 2 is left-sided. Question number 3 is right-sided. Okay. After that, now I want to test whether DBP, diastolic blood pressure, is same for the African American and Caucasian. Okay. So I want to test that one, which could be done. Which could be done by writing this. Okay. So we have found that 95% confidence interval is this negative 1.31 and 2.65 and p value is 0.51. So that means like the average diastolic blood pressure for the African American and Caucasians are same, that null hypothesis is accepted, or in other way fail to that hypothesis to be rejected. Okay, because p value equal to what? Are you saying p value equal to this 0.5107? Okay, p value equal to 0.5107. So the hypothesis that diastolic blood pressure for the African American and Caucasian are same. Alternative hypothesis, they are not same. So is not equal to same. So that hypothesis, null hypothesis failed to reject. Failed to reject. We failed to reject null hypothesis. So that means we accept null hypothesis. Understand, right? One line of code, right? Are you seeing one line of code, right? So if you become master on these things, okay, so your exam will be very just like this. Okay. No persons on the planet of the earth become an expert unless he gave lot of efforts. Understand? He provide lot of efforts. Nobody. So I am giving you, but if you do not practice, you will be the loser. Everything is well documented, right? All class materials are recorded, materials are given, everything was given. Okay. So once you enjoy, you study one step and then work hard, go to the next step, next step, next. In that way, you will end up with finishing your piece. Any people who got success, they have worked days and nights. Please take my advice and work that way. Okay, now come to the question number 4 is done. Test whether proportion of smoker is 0.25 or not. Proportion of smoker. These are the same thing, okay? These are the same thing, so I'm not going there. Proportion of the smokers are the same. So I want to find here table. Take a look at that. I run these things in here. Smoker. And then there is a 47 smoker, 1393 non-smoker. Okay. So I want to test whether a smoker is 25% or not. That is what I want to do. This is what I want to do. So p value is less than 0.05. So we reject the null hypothesis. Similarly, this is true for the right sided and left sided, left tail and right tail. Okay. Clear? Okay. After doing this, now I want to test whether um, this is called probe test. Probe test means I want to see whether probe test here. I want to see whether like proportion of smokers between African American and Caucasians are same or not. See, African American people, there is a smoker, right? And Caucasian people, there is a smoker, right? So I want to see whether proportion of African American smoker is equal to the proportion of Caucasians. I want to test whether these two proportions are same or not. That could be done by running question number 6, I guess. Yeah. So question number 6. Question number 6. Yeah. Let me check the question 6. Test equilibrium proportion for smoking when raise equal to 1 and raise equal to 2. Okay. Okay. Now question number 7. Conduct a pairwise t-test for S, BP and DBP. Okay. Now t-test pairwise. If you want, you can leave. Yeah. Okay. Pairwise t-test means what? So if I take her blood pressure continuously for next 30 days. So at the same time, her systolic and diastolic coming, right? To measurement. So that means data is coming in pair. Understand? When data comes in pair, then it is better to run pair t-test. If you go to a pond or lake and collect the zinc level at the surface water and bottom water, so that means it is coming at the same time, same places, right? The position is different. Okay. If data comes in a pair, then we have to run a pair t-test. Okay. To check whether the mean are same or not. So those could be done by question number 7. which is this. Again, in such a cases, you will just take a look at the p-value. If p-value less than 0.5, reject the null hypothesis. If p-value is greater than 0.5, fail to reject the null hypothesis. Understand? After that, now come, I want to check um, conduct test whether variance or DBP is 60 or not. I want to test whether variance of DBP is 60 or not. In order to do that variance, we have to run or install two packages no, known as these. After running these two packages, it is already installed there. They will say it is okay. Now I want to test whether sigma equal to this or not. So this is the results. Okay. P-value is less than 0.05. Okay, we reject the null hypothesis that variance is 110. That null hypothesis is rejected. Okay, because p-value is less than 0.05. This is less than 0.05. Okay, so mainly in here we are testing mean, equality of mean, proportion, equality of proportion, variance, equality of proportion, and then equality of several mean, which is known as the ANOVA, equality of several variances, then median, and then equality of several distributions, which is non-parametric Kruskal-Wallis test. So we want to check whether they behaves in a similar fashion or not. Test of hypothesis, we are testing that way. Okay. Okay, after doing this, okay, ANOVA means what? Suppose equality of several means. Okay, several means. Suppose I want to find how much money is spent for the entertainment by the freshman student, how much money on an average spent by the sophomore, how much money on an average spent by the junior and senior. So there are four group, right? And there are four mean, right? I want to check whether these four mean are same or not. In order to do that, we have to do ANOVA test. Analysis of variance test. Okay, but suppose I do not know their mean, I want to know whether the data is coming from the same distribution. Same distribution means they behave in the same manner. Okay, in such a cases, when you do not know the variance of the data and variance are not same. So freshman student variance is equal to the junior and senior and sophomore. If the variance is the same, then we can do the equality of mean test by ANOVA test. Equality of mean test by ANOVA. But if I do not know the variances and do not know their means and distribution, so in that case, it is called the non-parametric ANOVA, known as the Kruskal-Wallis test. Okay. So question number 8, I run equality of variance test. Now question number 9, I am running whether the variance of SBP is same for the race 1 and race 2. That is the question number 9. Question number 9 is telling you bar dot test SBP and race D3 and alternative two-sided, and we are running this. We got these values. So F value is 0.95. So that means the SBP variance for the SBP for the African American and Caucasians are the same. So that means null hypothesis we fail to reject. So when you use any software like the R, Python, SAS, or SPSS, MATLAB, or Excel, whenever you will use, you will always end up with getting p-value. And p-value, you will decide p-value less than 0.5, reject null hypothesis, p-value greater than 0.5, fail to reject. That's the way you have to work, okay? Any software you will get these things, okay? Yeah. Hmm. Clear? Okay. Then come the equality of test whether median SBP also test equality of variance for the variable SBP and DBP. Now I want to test whether SBP and DBP variance are same or not. Mm, okay, I okay, that one for some reason ignored in here. Okay, I will add this later. Okay, so now I want to test whether the median of the SBP is 100 or not. That is the question number 10. If I run this, I will get this value. Our p value is 0.34. So that means we found that like the median of SBP is 100. That is true, and we fail to reject the null hypothesis. Okay. So, and then I want to check whether the median SBP for the African American and Caucasians are same or not. Whether two median are same or not, we found that one after running this line of code. We found that median are not same. African American and Caucasians, their medium SBP are not same because p value is less than 0.5. The question number 12, we want to test whether median for SBP and DBP are same or not by running two-sided median test where SBP and DBP. We found that they are not same. Okay. Now I want to test whether SBP is normally distributed or not. Okay. Now we want to check whether SBP is normally distributed or not. That could be done. That could be done by running this. Okay. That could be done by running this Safiro dot test. And we see that SBP is not normally distributed because p value less than 0.5. So whether a variable, when there is a quantitative variable, you construct histogram and you add top middle point of the each bar, and if you get the frequency curve, if that frequency curve looks symmetry, then data follow normal distributions. That is by visualizations. But how can I test it numerically? That test is known as the Shapiro-Wilk test. Shapiro-Wilk test, p-value less than 0.5. That means SBP is not normally distributed. Understand? Clear, right? I have provided you document. If you are stuck with anything, please read the document. That document make your life easy. Okay, after Shapiro test, I want to test whether two variable blood pressure category and weight category. CW means categorical weight variable. Okay, I want to test. So, okay, independency is tested by the qualitative variable. Here is a smoking status, and here is a alcohol consumption status. Okay, alcohol consumption status means no alcohol consumption, moderate alcohol, and extreme. Okay, and here is smoking status 0 and 1. I want to check whether smoking status and alcohol consumption status, these two variables are independent or not. Okay, so that could be done by using chi-square test of independence, which run whether the blood pressure category, question number 14, blood pressure category and categorical weight variable are independent or not. After running this, we got p-value less than 0.5. We reject the null hypothesis. What is the null hypothesis? Null hypothesis is that weight category of the weight variable and blood pressure category variable, these two variables are independent, and that null hypothesis is rejected because p value is less than 0.5. Okay, p value is less than 0.5. Okay, after this, now I want to check. Suppose data is coming some places. Okay, I want to check whether the data is random or not. Is the data follow random pattern or it is coming by a system? First, this will come, then second will. That is called the randomness test. Okay, randomness test. That randomness test could be done by installing one package known as the random test. And after doing that, I want to check whether SBP, BMI, and income, these three variables are random or not. Okay, I want to check that one. Okay, after that, now I want to go and show you what is ANOVA test. Okay, take a look at the question number 16. I write here question number 16 on line number 127. Okay, line number 127, I have written AOV, analysis of variance. Okay, analysis of variance, SBP. SBP means systolic blood pressure, and there is a CWT, categorical weight variable. So categorical weight variable has a category 1 less weight, medium weight, and then category 3 is the heavy weight. Okay, so I want to see whether the mean of SBP for each category of the weight variable are same or not. So there are three category labels 1, 2, 3. 1 stands for less weight, 2 stands for medium weight, 3 stands for heavy weight. For each weight, there is a average systolic blood pressure. I want to check whether average systolic blood pressure are same or not for each of the three weight category variable, and that could be done by running analysis of variance test. Take a look, chi-square test and F test, which is analysis of variance test, are only positive. There is no negative. There is T and Z distribution is a symmetric. Some value negative, some value positive, right? The guy said T and Z is symmetric, right? But chi-square and F distributions, this is always positive, 0 to infinity. If someone asks me draw the chi-square curve or F curve, it should be like this. This is the normal. This is the T. Okay, and F and chi-square is this. This is the F and chi-square. So this is very long right tail. Okay, very long right tail. Okay. Okay, so after that, analysis of variance is done. Now I want to check whether there is equality of several means. For each weight category, there is a systolic blood pressure. There are three weight category. Corresponding to each category, there is a three means of systolic blood pressure. We want to test this. Similarly, corresponding to each weight category, there is a three variances. Three weight category, three variances. I want to check whether the three variances are same or not. Okay, that test is known as the equality of several variances, known as the Bartlett test. Very famous. This Bartlett, I think he was in maybe Iowa or University of Chicago, something. No. University of Chicago is Kraskell Wallis. Bartlett, I think, in Iowa State. He developed this test of hypothesis in their Iowa State University. So this is the equality of several variance test. Okay. So df equal to that, test name is this, p value is that, so we reject the null hypothesis. Okay, p value is 0.01, which is less than 0.5. Okay, we reject the null hypothesis. I want to test whether the correlation for SBP and DBP are same or not, which could be done like this way. Okay, whether the correlation of SBP and DBP is zero or not. So that null hypothesis is rejected. So question number 18 is saying you test whether correlation between SBP and DBP are test whether height and weight are correlated or not. That is the question. Okay. What did I put here? Okay. Question number 8 should be height and weight. HT, and WT. Okay. HT and WT. Now I want to find four variable height, weight, SBP and DBP, and want to construct the correlation matrix together with their p value. This is called the pairwise correlation matrix. So if I run this, you will see. So this is the correlations and this is the p value. Okay. So what does this means? This means correlation between DBP and height equal to 0.10. Is the height and DBP highly correlated? The question is HT and DBP are not correlated. The alternative hypothesis is that they are correlated. So p value is 0. So that means null hypothesis is rejected, which states HT and DBP are independent. Okay. Okay, so let me explain these things again. What does this mean? This means SBP and DBP has a correlation 0.32, right? So null hypothesis is SBP and DBP are independent, and alternative hypothesis they are not independent. Since the p value is 0. So that means the null hypothesis that SBP and DBP are independent, then that null hypothesis is rejected because p value is less than 0.05. Understand? When you run this code, when you go through this problem, you can ask me question by email, like Professor, in this document on this problem, I ran this code, I got this output, and I do not understand. My understanding is that they are not correlated because p value is less than like that. Is this true? If you formulate questions like this way and email me, I will immediately respond when I see it. Okay. Okay, then question number 20. We want to check question number 20. Let me go and check. Run a Darwin-Watson autocorrelation test. Okay. What do you mean by autocorrelation? See, when you collect the data by time, that is called the time series data. Time series data is automatically found to have correlation. On what? Their errors, the residues. Okay. That could be checked by the Darwin-Watson test. So, like whatever most highly used test of hypothesis problem, all of this problem have been put in there. Okay. All of this. So now that could be done by running this, and package is 0.6641. Okay. 0.6641. Now, as I said to you, Kruskal-Wallis is a non-parametric ANOVA which will tell you whether data is coming from the same distributions or like a certain threshold value, like if it exceeds a certain value, whether they are from the same or not. That could be tested by Kruskal-Wallis test. They are testing whether the by 9 income group, corresponding to each income group, there is a SBP level. Like income group 1 has a SBP, income group 2 has another SBP. I'm talking about the mean or median SBP. I want to check whether those are the same or not. That could be tested by the Kruskal-Wallis test. Okay, this is the Kruskal-Wallis long sum test. So P value is 0.14, so we fail to reject the null hypothesis. Okay. Question number 22 is telling you conduct Fisher's exact test. Fisher's exact test, we can run it when the cell frequency is less than 0.5. In such cases, Fisher exact test is better than chi-square test. Remember, when the cell frequency is less than 5, it is better to use Fisher's exact tests. Okay. A main Whitney U test is same as the Wilcoxon rank test. Okay, it is a non-parametric statistical used to determine if two independent groups are differ significantly on a single variable, especially when the data is this rejected. Same as Wilcoxon test, which I already did. Okay, so this is the all discussions about today's class. Is a short class. I have 1 hour 10 minutes. If you have a question, I know you have a question, I'll go over with you. Anyone else have any problem with running the code or any other thing? No, right? So then I can spend some time with that. You do not have a question, right? No question with you, right? Georgia? Georgia, right? No. Oh, we don't? You, okay. No, your country is Georgia, right? You, okay. You have question? No. Let me help. So you say that your data is not coming to the R?
Yeah, I was thinking this year, but from last couple of weeks, I was a little confused.
Okay, so here is your R, okay? So this is your advanced computing, okay? I know maybe many of these things you do not know what is going on there, right? But read the document things. The project does not have any questions from here, okay? Project has all the questions coming from OpenPy. Come, and then why did you create my folder?
Oh, it should be a download.
Download. Why you should create a folder by my name. I'm your professor.
I took out the laptop, so I'm
Okay. So where? This one, no. This one. Let me see. I saw something. This one, right?
Yeah.
This one I have opened. Okay. So this data is open, right? So now you also save your data in that location or no?
Yes.
Is
I need to create a folder.
You need to create a folder. Okay. So how about let me do these things for you.
Okay.
Let me. Yeah. You're free to go. So I just go there. You sit down with folder.
Yes.
Data. How did you save the perspective?
It should be. The class data for today,
In last week.
last week, that's not.
No, this is not the
Let me just
see this.
save it. I'm gonna create a folder too.
Yeah.
I didn't realize how disorganized.
Yeah.
It was. This one, right?
Yeah, this doesn't this other.
This one?
Yeah.
Okay.
This one.
Oh, sorry. You wanna open it?
It is always safe, right? Download photo.
Okay.
There. So now what you will do, you will go there, go to the download folder. Now see data is in there, right? So you can come double click in here, go to the properties, then copy this thing. Okay, copy this thing, come in here. Come in here. Just plug it in there, control V. So now change it to this one, this. Okay, so now let me run it, control enter. It is running now. Fantastic. So you don't need these two things. Okay, you just directly run it. Okay. So now you data run. Here is your data. Now take a look at that. If you read the Word document and run it, control enter, we have 20,925 columns. Okay. Now if you come in here, run the one, see all the variables names, right? Are you seeing that?
Yes, sir.
And then structure, right? Control enter. Right, see, this is the integer, this is the numeric variable, there is some character variable, no character variable. Integer and numeric variable, okay? So now if you want to take a look at the first 6 row, this is the first 6 row, okay? And first 6 row. If you want to take the last 6 row, I think. So come in here and control enter the 6 row, okay? This is the first 6 row. Now everything is in there, you will go, you will work, okay? Read the word document with all attention. Each line and then run. But I think the materials that I have given is a lot of material, and your project is very simple. The stand problem very simple, and project question all coming from these documents. No advanced computing, no function, no series computations, no creating sequences, nothing.
Okay.
This is just from there. Okay.
Okay.
So run it, and then it will become easier for you.
Okay.